I should brag on you. Everything that was left in the note was positive about you yesterday. No one was called out by name, which is kind of a good thing, because unless it's in a positive way, you don't really want to be called out by name. Yes, dear. I do. What was 2 days ago was 17. Go look in the back of the 17 spot. I put all my extras there. I was going to walk around and check your page 2 and 3, but the sub left me a note and said that everyone except one person had it done, and that person showed me he has it done. So I'm going to just give everyone points for page 2 and 3, unless someone wants to confess. At least that's what the sub said. So you were supposed to yesterday. There was a video, and one time I made a typo, by the way. I made an error. And 2 people caught me in second period, commented on YouTube, and are going to get extra points today for it.
Was it like the top?
Yeah. Okay, so if you know where my error is, it's terrific. Just know it was an accident. And the main principle is right, and even I make mistakes in life, so sorry. So I was going to check to see if you actually had these done, but the sub said you did. And she said you had this page done as well. I told you could skip 19 and 20. Let's do those quickly now together. If you skip them, you're just scared of substitution, which you shouldn't be because you've already spent a lot of time on it. So if we're looking at 19, actually let's do 20 first. So what we learned with matrices is that the top line are supposed to match. So x is supposed to equal 4y. And the bottom lines are supposed to match. So 3y is supposed to equal x minus 3. And I get we're mad at it because that's 2 equations with 2 different variables, but my God, that's all you've been doing lately with substitution, elimination, and graphing. So since x is 4y, everywhere in that second equation I see an x, I'm going to put 4y. So I'm going to substitute. So 3y equals 4y minus 3. I get negative y equals negative 3, so y equals 3. So let's say that again. Table 5 out of point, 6, 3, 4, 2, 1's the only one that was talking. Okay, so again, I've set these 2 equations equal to each other. I was mad like you because they had 2 different variables, but since x equals 4y in that top equation, why not everywhere in that second equation I see an x, I plug in 4y and use substitution. I end up getting y equals 3, and then I can plug that into either equation. I think it'll be easiest to plug in the top one. So I plug in 3. It used to be x equals 4y. I just found out that y is 3, so x equals 12. So I admit 20 took a little extra time, but it's just a combination of what we're learning about matrices and what we just tested on. Okay, we could use that same principle with 19. So the top equation is 2x equals 6y. The bottom equation is y plus 2 equals x. Well, don't I have it set up perfectly for substitution with the second equation? If x is y plus 2, everywhere in the top equation I see x, I'm going to put y plus 2. So instead of 2x, I've got 2, y plus 2 equals 6y. So 2y plus 4 equals 6y. 4 equals 4y. So y ends up equaling 1. And you can plug it back in. Yes, dear. It is not focused. You could, and then everywhere you see y, put x minus 2. You're going to end up with the exact same numbers. It doesn't matter. You could be fancy and use the top equation and say x equals 3y and divide by 2 on both sides. And then plug in that top equation into the second one. Substitution doesn't matter. You get to substitute how you want. It's kind of like with football. Like, you don't have to put in the second string quarterback. If you're mad at him, you can go to the third string once the first string guy's hurt. It's up to you.
That would be dumb.
Yeah, it tends to be, but
Can you scoot over to the toilet?
I can. Okay, so I got y equals 1. Hold on. I'll scroll over there for him. I got y equals 1 on 19, so what does that mean x equals? Yeah, x equals 3, because 1 plus 2 is 3, so x equals 3.
I guess that too.
You can have a point for that. So, why are you being so finicky today, Hubbercan? So x does equal 3. Come on, Hubbercam. I just told you autofocus lock. What's the deal? Okay, again, I appreciate how well behaved you were with the sub. And there are things you don't know that I guess I should tell you. I leave all my stuff here when there's a sub. So I forgot to plug it in, but I don't care if Mia comes over here and looks behind the cabinet and finds the charger. The charger was here. I just had to, someone in second period commented on YouTube, so I understood you had an issue. Send out an SOS to me. I'll help you somehow. And so they sent out an SOS to me, and I sent Ms. Asbury down here to find the charger and plug it in. So if there's an issue next time, I know it's not often people want to be talked to when they're not at school, but it's fine with me if you comment on YouTube or post on Google Classroom or whatever. Email me, let me know what's going on so I can help you. Because I know you're trying to be productive, and I hope you're hooked on Wi-Fi because we had to use your data to watch that 10-minute video. I'm so sorry. So very sorry. You weren't even in here.
I wasn't. Not on my phone.
Okay, are there any questions about this? Yes, dear. Yes. Okay, that's a good question, and you can have a point for that. Did anyone else have another issue like that on this worksheet? So 8z equals 4z. So you divide, and you get, if you divide by 4, you've got 2z equals z. If you divide by z, you end up getting 1 equals 2. That's crazy. So what's the only number z could be to make this make sense? Z has to be 0. Because 8 times 0 is 0. 4 times 0 is 0. Other way, this is never going to work out. Z has to be 0. Or, so you had, at this line, if you're still mad at it, you had 2z equals z. You can't see what I'm doing. You had 2z equals z. If you subtract z from both sides, then you would have z equals 0 for real. But I just knew when it was 8z equals 4z, the only way to make that statement possibly true was for z to equal 0. Okay, what number did you say you were mad at, table 3? 17? So you got x equals 9, y equals 4, and z equals 3. So on 17, I have x equals 9. Then I had 16 equals 4y. Divide by 4, you'll have 4 equals y. And then with 3z equals 9, if you divide by 3, you get z equals 3. So it should be 9, 4, 3. Does anyone else have any other issues on this worksheet? Okay, well then, let's go ahead and do the math workshops that I circled today. It's 1 through 4. And while you're doing it, let me remind you about why we love matrices. So matrices, we have to figure out the dimensions in the matrix, and that's going to be really important today. But with addition and subtraction, life works exactly like you think it should. And if you multiply by a number on the outside, we call that a scalar. Life works exactly like you think it should. The only time matrices are a pain is when we have to multiply, which is what we're going to tackle today. But if you pay attention, it really is like a set process. It's just not what you would have expected. Okay, number 1 says 192 x to the 4th y plus 60x y to the 5th. Can someone tell me what my first step should be?
Okay, let's go on.
Paige gets the point. You're supposed to find the GCF. So what's the GCF with, I know it's x and y. Well, what number am I supposed to pull out?
X, 60,
It's 192. It's not 19, it's 192.
Oh, that's 190.
Yeah, I just circled it weird. It's 192. So I need a number that goes into 60 and to 192. 12, is that the biggest? Eduardo's nodding yes. Anyone else going to confirm this for me? No, there's a bigger one.
24.
24, does it go evenly into 60?
You know what?
12 sounds nice, and if it's not the biggest, then we'll realize it shortly. So let's pull out 12.
Wait.
What's 192? And you can get a point for that for now, Hunter. We'll let you keep it regardless. What's 192 divided by 12? 16. So 16x to the third. And what's 60 divided by 12? Then that is correct, because 16 and 5 don't have anything in common. Y to the fourth. So he's correct. I don't know why I was questioning him. How many terms are there on number 2?
4.
So what are we supposed to, and you can have a point for that. What are you supposed to, you can have another point for that. We're supposed to do grouping. So, we put them in groups. What do I factor out of that first group? Say it again, ma'am. Oh, no. What can we factor out of that first group? You're going to point for that. If we factor out an x squared, we're left with an x minus 5. In the second group, why don't we factor out a negative 3? What would we be left with? Then what? Oh, and we would have a problem. So instead, let's factor out a positive 3. What would I be left with then? Okay. So you see how I caught myself and corrected it. Why did I know to make that correction? 3 and 4, because I knew I wanted these to match. Yep. So my final answer is x squared plus 3, x minus 5. If I wanted to check myself, what method could I use?
FOIL method.
Archie will get a point. Okay, number 3 has 3 terms. There is no GCF. So we've got to go and factor like normal. We need to know 2 things that, and the leading coefficient is 1, so it gets to be normal factoring. 2 things that add to give us negative 3, multiply to give us negative 4. And I want to go straight to the answer. What plus what adds to give you negative 3 and multiplies to give you negative 4? 3 and 1, 3 times 1 is 3 though.
Negative 4 has
4 and 1.
It has to be 4 and 1, and it's negative 4 and positive 1. 1 and 2 get a point. Negative 4 plus 1 is negative 3. Negative 4 times 1 is negative 4. That is correct. Perfect. If you need to write it out and think it through, you can. But I'm just trying to save us a little time. Okay, the last one, number 4, is my favorite one of today. And don't tell me we can't do it, because we can. We can. What do you notice about 81? What's special about that number? Yes, Mia. You can have a point for that. It is a perfect square. What times what is 81?
9.
I said that. I didn't say that. I said 9. No, 5 times.
So it ends up being d plus 9, d minus 9. Anytime you see a perfect square, something probably special is going on. And if you're questioning my sanity here, we FOIL it out. We would have d squared, negative 9d plus 9d. The outer and the inner would cancel out. Positive 9 times negative 9 is negative 81. So I love when I see a perfect square and only 2 terms. Life tends to work out real nice. Okay, let's go back to matrices and let's talk about today. If you want to come get a calculator, we are going to get to use those in just a moment.
My Nana gave it to me. I didn't know I wanted.
You get 22.
Yes, please. Okay, we're going to do Bless Your Hearts. I know you just came and got a calculator, and I'm going to show you how to do it on the calculator momentarily. But we also need to know how the system works anyway, because, again, I'm thinking standardized tests and trying to be prepared for the ACT or whatever test you might face in life. They're not necessarily going to let you have a fancy calculator. They do for the ACT, but not necessarily in college. And more than that, they might ask you about a specific element, meaning a specific spot in the matrix, and you need to be able to explain how you got the number you did. Okay, so we were talking about matrices, and you have to give the dimensions. That's what we went over first. So let's look at number 1 at the bottom. What are the dimensions of this matrix, these two matrices? And the other one is a? In fact, let's go ahead and do all of them. So this is a 2 by 2, a 2 by 2, 2 by 2, 2 by 2. You can have a point if you can remember what vocab term I said goes with those. Hunter, get a point. If it's the same number, like 2 by 2, 3 by 3, it's called a square matrix. 3 rows, 2 columns. 2 rows, 2 columns. 2 by 2, 2 by 2, 3 by 2. I'm doing each individual matrix, and we're going to talk about why we have to do that in just a second. So the first thing we're going to have to do today is kind of what you had to do yesterday anyway. You need to go ahead and determine the dimensions of each matrix, because sadly, that's really going to make a difference today. In fact, what's super annoying is, you know how yesterday they had to have the exact same dimensions in order to add or subtract? Mm-hmm. They don't have to have the exact same dimensions in order to multiply. So if you were thinking we were going to cross off number 9 or we were going to cross off number 7, you may or may not be right or wrong. Just because they're not the same dimensions doesn't mean we can't multiply. There's more to it than that. Okay, so the directions at the top explain how to do it. If you want to read it from someone other than me, you can read that above. But I'm too excited, so I want to tell you how I think it through. The first thing you do after you label all the dimensions is you've got to make sure the number of columns for your first matrix matches the number of rows for your second matrix. So we can work number 1, we can work number 2. If they don't match, we can't work it. So what's the first problem today we're not going to be able to work? In fact, the only problem we're not going to be able to work. Yes, Abby. Abby, get a point. Okay, so number 7, 2 and 1 do not match. It does not have the same number of columns and rows with the next one. So if the 2 inside numbers do not match, it's not possible or impossible. Or we're not doing it. I don't care what you put it, as long as you don't try it, because it won't work. So the first thing we do when we multiply is we need to go ahead and determine the dimensions of each matrix in order to make sure multiplication is even possible. Okay. Do you know how addition made sense? Like you were supposed to add, go zoom in on number 1. That is a 3, right? Yeah. That number I've written on top of, is it a 3? Yes. Okay. So, you know how you were supposed to do 4 plus 3, 1 plus 0, negative 2 plus 0. Like each element had one friend. Sadly, multiplication doesn't work like that. Multiplication ends up being an entire row goes with an entire column. So for instance, for our very first entry, and I'm going to do it in colors because, you know, I'm colorful. So I've got a lot of colors. If you want to get out a lot of colors, that's fine. We're going to do our first row with our first column. And when we do this, so A times E and then plus the next thing, that's how we're going to determine our first element. So first row, first column gives you that first entry. And then first row, second column gives you that top second entry. And you're like, okay, well, we've got, 2 entries. Now I think I need to go to the bottom. You're right. Second row, first column gives you the first entry in the second row. And then second row, second column gives you the last entry. So we're going to do row times column until we fill up our top. And then once we're done, we go and do the other row times the columns. And if it had more rows, we would do more rows times the columns. Okay, and maybe that did or did not help. I swear we're going to do a couple, and then we're going to talk about how you can make your calculator do it for you too. But before we go crazy, let's look at 1, 2, and 3 at the top that I was trying to skip. So the top tells you that there are 3 matrices, or actually there are a couple of them. There's 1, 2, 3, 4, 5, 6 matrices. One is A, it's 2 by 4. B is 4 by 3. Since these inside numbers match, we are going to be able to do it. The inside numbers don't match on number 2, so it's not possible. The inside numbers match on number 3, so we are going to be able to do it. But the reason I'm coming back to that is you're like, okay, so the inside things have to match. Well, then what do the outside things tell us? They tell us what our answer is going to be, what our product is going to be. So when we multiply matrix A times matrix B, we're going to end up getting a 2 by 3. If we multiplied, we can't do number 2, not possible. But if we multiplied number 3, we saw the insides match, so my final matrix would be an 8 by 10. And all that helps me know is what my answer is going to be. So looking at our number 1, we're about to work it out. What's the dimensions of that matrix that we're going to get when we multiply? It's going to be a 2 by 2. Get a point. The first one that's not a 2 by 2 is number 4. What will we get on number 4? 2 by 3. Get another point. Okay. So again, and I'm going colorful. Hunter is right. It's going to be a 2 by 2. I'm going to multiply the first row times the first column. So I'm going to do 4 times 3, which is 12, plus 1 times 0, which is 0. Now, if you want to write it out so you have, that's fine. If you want to go straight to, I know that the top left number is 12, that's fine too. To be honest, I normally do it in my head, but I can write it out today so you understand where I'm getting these numbers from. So I did 4 times 3, I got 12, plus 1 times 0, which is 0. Hence why my top left entry is a 12. Now for my top right entry, I'm going to do that first row again, times that second column. So 4 times 0, which is 0, plus 1 times 3, which is 3. So again, that second entry is going to be a 3. And if you jump straight to the answer, that is perfectly fine with me as long as you're not making mistakes, because I tend to. Okay, but Hunter already told us our answer should be a 2 by 2, so I know I'm done with that first row. I need to go to that second row. So I'm going to do the second row times the first column. So negative 2 times 3, which is negative 6, plus 3 times 0, which is 0, and I get negative 6 for my first entry on my second row. And for my last entry, I'm going to do second row, second column. So negative 2 times 0, I get 0, plus 3 times 3, which is 9. So my very last entry is a 9. So if we were to really multiply those two matrices to begin with, our resulting matrix would be 12, 3, negative 6, 9. Are there any questions about number 1? Does everyone understand how I'm doing this? Okay, well, I'm going to keep doing it a couple more times, but you need to speak now or forever hold your peace, because I'm going to think you got it, and I'm going to be sad if you don't.
Is it always going to be like 12 plus 0?
It's not always going to be zeros. That matrix is really nice because it had a lot of zeros in it. I'm super excited when I see a matrix with a lot of zeros. It makes my life so much easier math-wise. So the next one that would be fun, there is no other one that is that fun because no one else has 2 zeros. They stink. Bummer. Okay, so number 2, first row, first column, I'm doing negative 3 minus 9 and I'm going to end up getting negative 12. But if you need to write out negative 3 minus 9 to then write negative 12, I understand.
It's 0.
Ooh, that's a 0?
Yes.
Oh, I thought that was an... Oh, okay. I didn't understand that was a 0. My bad. I wrote on top of it. I appreciate... Bless you, Day. You can have a point. So, it's just negative 3. It was negative 3 plus 0 times negative 1 is 0. So, it ends up being negative 3. I thought it was a 9. I need to get some glasses. No. My second entry is, again, top row, second column. So, negative 2 plus 0. I get negative 2. And then page, that's where the fun ends, because all the other ones are straight up numbers. So I'll do my second row, my first column. 3 times 3 is 9. 7 times 1 is negative 7. So 9 minus 7, which is 2. And then I'll do my second row, second column. 3 times 2 is 6. 7 times 4 is 28. So 6 plus 28, which is 34. So we should get negative 3, negative 2, 2, 34. I like it.
You're a math teacher. You're supposed to.
Yeah. Okay, so I'm going to give you a second and someone tell me the answer for number 3, because it's another 2 by 2. Let's see if you can get it before I can. Hunter, I heard most of the entries. Say it again.
7, negative 7, 14, 14.
That's what I got. You can have a point. No, and in fact, if you didn't show any work, I wouldn't have showed any work either. The only reason I'm showing work now is to show people what I'm doing in my head. Okay, on number 3, I got 7, negative 7, 14, 14. And then anyone mess up an entry they need me to go over? And then we'll do number 4, and then we'll talk about a way to make our lives easier. Well, theoretically. Theoretically easier. Depends on how tech savvy you are. Okay, number 4. What is my answer supposed to be? So it's different. All our other problems have been 2 by 2, 2 by 2, 2 by 2. So for this one, I should have 3 numbers, 1, 2, 3 on that top row, and 1, 2, 3 numbers on that second row. But that makes sense because there are more columns now. So I'm still going to do first row, first column for that first entry. And this one I'm going to do in my head if that's okay. Negative 12 minus 3, I get negative 15. For my second entry, top row still, second column, 0 plus 1, I get positive 1. First row, third column, negative 3 times negative 2 is positive 6, plus 1 is 7. So you can see how sign errors could potentially be an issue in our lives. That is a 7. And now we're finally done with that top row, and we can move on to that second row. So 5 times 4 is 20. Negative 2, negative 3 is positive 6. So 20 plus 6 is 26. Five times negative 2 with 0 times 1. 5 times 0 is 0. Negative 2 for the other, so we just end up with negative 2. And for our very last entry, bottom row, last column, negative 10 minus 2, we get negative 12. And that's it. And that was a 3 by 2. I mean a 2 by 3 because it's got 2 rows, 3 columns. But again, we know what the answer is going to be because of the outer 2 numbers. The inner 2 have to match for us to do it, but the answer is going to be the outer 2 dimensions. So it's a 2 by 3. Okay, is there anyone who is confused? Yes, dear. Which entry? I did 5 times 4 and got 20. Negative 2 times 3 and got positive 6, so 26. 20 plus 6 is 26. 5 times 0 is 0. Negative 2 times 1 is negative 2. Negative 10 minus 2, negative 12. Yes. But again, I was showing it out before, like I did on number 1. If you want to continue to do that, you can. I get lazy and I just do it in my head. But if you make a typo or a sign error, which was very potential there, then it's kind of hard to catch. I say it's hard to catch, and I always check myself. How, Miss Compton, do you check yourself? I use something called a calculator. Get out your handy-dandy calculator. If you look at your fancy calculator, lo and behold, there is a button written in blue that says matrix. What key do you have to press to get to the blue buttons?
Second.
I heard it first from Steph. Get a point. Second matrix. So I press second matrix, and I see I have this whole list of alphabet letters that I can choose from. So you don't always have to stay in A. You can go crazy and use F or G and be different. But for now, we'll just stay in A. We want to scroll over to edit because we want to change that matrix. So second math, I got these lists of matrices. I scroll over to edit, and I'm going to edit that matrix. You type in the dimensions. So if we're typing in number 5, that very first matrix has 3 rows, 2 columns, so it's a 3 by 2. So 3, enter, 2, enter. And now I can type in exactly what I see on my paper. 3, enter, negative 2, enter, 0, enter, 4, enter, negative 5, enter, 1, enter. And now my calculator has the same matrix that's on my paper. And so as soon as I figure out how to tell it to multiply, it's going to do the math for me. My only gentle reminder is that when you're pressing the negative sign, make sure you're using the one that's in gray. Not the minus sign, the little negative sign for your entries, because otherwise it's going to tell you it can't do it because you picked the wrong sign. If your calculator tells you it can't do something, either 1, the matrices were not possible anyway, you should have checked out the dimensions first, or 2, Seth had made a typo. It's not the calculator's fault. Okay, so we typed in 1 matrix, so if we want to get out of this, you can press second quit. It gets you out of whatever you're doing. Second quit, it's right next to mode. It's right next to second too. Second quit. Clears it back out. Okay, well we typed in the 1 matrix. We still need to type in the next matrix too. So, second matrix. I typed in 1 for A. I need to type in 1 for B now. Oops. I didn't press edit. Second matrix. We need to edit the second one. Now, it would be silly if we said we were going to edit the first one again. We're wanting 2 matrices to multiply, so you need to use A and B, or 2 different letters. So we're going to go to B. Our second matrix for our problem is a 2 by 2. So I'm going to tell it 2 by 2. And then my entries are 1, 2, 2, 1. So 1, enter, 2, enter, 2, enter, 1, enter. And again, my matrix on my paper matches the one that's on my calculator screen. Okay, is there anyone confused about this? Yes, here.
I like it so.
Scroll over to edit. And then scroll down to B. Do it again. Okay, so now we have A and B both typed in, so we can multiply. So we're going to second quit to get out of there. But still, we need to pull back up those matrices. So second matrix. And now we're actually going to do some math with them. So I'm going to hit enter, and it's going to bring A to my screen. So I press second matrix, and I press enter, and it brought A. But now that I want it to bring B, I just need to scroll down one to B, and then press enter again. And now since we have A and B side by side, you know, that kind of implies we're supposed to multiply. So if I press enter one more time, it's going to do matrix multiplication for me. So if I were to work out number 5 by hand, that is the final answer I would get, pending I typed everything in my calculator correctly. So I press second matrix. Oops, second quit. I press second matrix. I press enter on A. Just enter. I press second matrix. I scroll down one to B. Press enter on B. And if you press enter one more time, your calculator understands that's multiplication, and it gives you the answer. But this is all pending that Braxton has typed this correctly in his calculator. If he's not, he's SOL. So maybe he wants to check himself by hand too. That would be the wise thing to do. But we all know we're going to be lazy probably from here on out, and most of us are going to calculator it. Literally, yes. I can top that. You can add and subtract with them too. As long as you know how to type in the matrix, we're about to make it do some crazy things. So, does anyone need me to do any more of these?
Can you do number 9 since it has more rows and everything?
Yes, I will do number 9, and we'll leave the other ones 6, 7, and 8 for you. So number 9, I'm rebellious. Instead of typing over what I did in A and B, I'm going to go down to E and F. Oh, I did not press edit. Second matrix, I'm going to edit matrix E. I want it to be a 3 by 3. My first row is 2, 0, negative 3. 2, enter, 0, enter, negative 3, enter. 1, 4, negative 2. Negative 1, 3, 1. Whoa. So it knows the first part of number 9. Now to type in the second part of number 9. So I've got to go to a different matrix. So second quit, second matrix. I'm going to edit, let's say, letter F this time. Doesn't matter as long as I don't do the on top of the one I just did, because that would be stupid. It is a 3 by 2. Its entries are 2, negative 2, 3, 1, negative 2, 4. And now my second matrix is also in my calculator. So I'm going to quit out of this. I'm going to clear my whole screen so you can see what I do. If I press second matrix, I need E, enter. Oh, it just brings up E. Make sure you type in both of them. So second matrix, I need E. Second matrix, I need F. Because I want them multiplied together. E times F. There's the answer. But at the same time, that kind of makes sense, and I feel like, well, I might have made a typo because I'm human like you, but I knew my answer was supposed to be a 3 by 2, and the answer is a 3 by 2. So my calculator is really good. Look at it go. And in case you didn't hear Gracie, let me tell you her genius question. Can I make my calculator do other things with matrices? Yes. You could type in, if this was a plus problem, you could still type in this, and make it add for you. Now, you and I both know the addition ones were kind of easy, so you probably could do it faster in your head. But with the subtraction ones, because I know I make sign errors, it might be smarter to do it like this. From here on out, you're allowed to use that handy-dandy calculator. In fact, it's going to be our dear, dear friend very, very soon. Because there's one more complicated thing we're going to do with matrices, but not today. Okay, yes, dear.
When you're done, how do you erase?
Second quit gets you out of everything. If you're wanting to clear off the whole screen, really just press clear.
Yeah, but whenever you go to the matrix, it would still be that.
Yeah, so if, he's wanting to like completely clear the list. Yeah. So if you went to edit, you can press, it really would be just easiest to leave it there, to be honest. But if you're wanting to kill it, second quit. If you're wanting to kill it, a way to clear your whole calculator is second memory, and then tell it to reset or clear entries. Clear entries would probably be easier. So second matrix. Nope, that didn't work. You have to do reset. You would have to press reset and delete all your RAM, and it's like resetting your phone, so is it really worth it to you? I don't know. That was a really good question, Arturo. You can have a point for that. And see, now my matrices are all clear. I bet there's an easier way I cannot come up with at the moment. It's never bothered me that those are still stored. But maybe it should. If you just went to second matrix and press clear on it at the top. I don't know. That's a good question, Arturo. Okay, are there any questions about this? The other three are yours. Type them in your calculator, get the answer. That's all I need from you today.